Alright, this next section is going to be about phase changes. Phase changes happen when you turn from a solid to a liquid, or a liquid to a gas, or vice versa. So we're going to talk about the different types of energies that are associated with phase changes. The first one is heat of vaporization. Heat of vaporization happens when you change from a liquid to a gas, and it's the energy required to do so. So it's the energy you're going to add to your compound. So when you change from a liquid to a gas, you have to heat it up so there's more energy required. Heat of condensation is energy release. So here you had to absorb energy, here you're going to actually let energy go. And it's when you change from a gas to a liquid. Liquid water and steam both exist when you're at 100 degrees Celsius. So they both are there at 100 degrees Celsius. And this right here is our constant 40.7 kilojoules per mole, which we'll be using later. Energy and phase change, again the same thing, so we're going to talk about heat of fusion. Heat of fusion is the energy required to go from a solid to a liquid. Again, this is an energy required, so you're going to add energy here. Heat of solidification is energy that's released. You're going to get some energy coming off and change from a liquid to a solid. When liquid water and ice both exist at 0 degrees Celsius, at normal atmospheric pressure, of course. And this is for water's constant right here, for ice is being 6.0 kilojoules per mole. Here's a phase diagram chart. This is very helpful. Right here we have our calories, or our energy. And here we have our Celsius, or our temp. So you'll notice 0 degrees Celsius is where we have our ice, or where we have some lines here, and it's going flat. And here at 0 degrees Celsius, we also have a line that's flat. And we have linear lines going up. Yes, linear, straight line. Remember, math teachers love me. So we're going to go up. So some really cool things about this is that your temperature will not raise when you're at your heat of vaporization. Because instead of the temperature rising, the energy is going from changing from a liquid to a gas. So right here, the energy is not going towards changing the temperature, it's going to changing its state, breaking it apart, making it a liquid to a gas. Okay, and then down here, we have our heat of fusion. This is where we're going to go from being a solid to a liquid. So when we add energy here, we're going to add energy until we get to 0 degrees Celsius and get warmer until then, and it will not raise its temperature until it's a liquid. So it's really cool. So solids, it cannot be a solid, and all the energy we add, all the energy right here, this 80 kilocalories of energy go towards changing it to water. And then once we have more energy, we can increase more energy up, and then we can raise our temperature, and it will not change its temperature until it all becomes a gas. Some more important lines, again, is here we have ice, or a solid. Here we have water, or a liquid, and we have steam, our gas. So this right here is this slope. These slopes right here are our specific heats. Those are really important. So our specific heats are what derived from these slopes. So on this line we have both water and steam. This is where it is changing from a liquid to a gas. So they are both existing here. As you start right here, you have mostly liquid and hardly any gas. As you get here, you have mostly gas, hardly liquid. So that's with how much energy you've used up. And it will not raise temperature until all of it has been turned to a gas. And here again we have ice and water. Same thing is true as before. We're going to raise our temperature until we get to starting melting. And the temperature will not raise until all of it is turned to a liquid.